I'm willing to bet that all of us have used paper at least once in our lives, whether it be random doodles during class or a 300-page thesis. Paper plays a very big role in communication and art, but how does paper work? In this video, we will go over the structure of paper, different types of ink, and how ink and paper interact as we go over capillary action and polarity. First invented in the 2nd century in China, paper is mainly made of cellulose fibers, which are found in the cell walls of all plant cells. One key property of the fibers is that they are hygroscopic, meaning that they are able to absorb water very well, and even when they are wet, cellulose fibers still have incredible strength and durability. Most plants also contain plenty of nonfibrous cells, which aren't ideal for papermaking, but luckily for us, a plant already exists that contain high amounts of cellulose fibers and not much nonfibrous cells, trees. Hence why most of our paper is made from trees. Lastly, paper is also a porous material, meaning that it has small holes for liquid and gas to pass through, which will be important for later. Now moving on to the other component of printing, the ink. There are two main types of inks, water-based and oil-based. Water-based ink is 33% pigment, 33% water, and 33% polar solvent that can dissolve in water. Some examples include watercolor, obviously, mountain pens, and gel pens. On the other hand, oil-based ink is 35% pigment and 65% apolar solvent that doesn't dissolve in water. Some examples include the ballpoint pens that everyone uses and pastel. Putting them together, how do the different inks interact with the paper and where are they used? When water-based ink touches paper, it gets absorbed into the paper immediately by capillary action, which is when a liquid moves through a very small space through cohesion and adhesion. Cohesion is the tendency for molecules to stick together, and adhesion is the tendency for molecules to stick to other things. So in the case of the porous paper, since water is highly cohesive and likes to stick to each other, and is highly adhesive to cellulose, water-based ink is quickly absorbed. However, water-based ink needs airflow to evaporate the water for the ink to settle, so it gets smeared easily and runs on the paper if it gets wet. This means that Sharpies are 100% not water-based. Though because of this absorption, water-based ink is less bled through and the pigment stays exactly where the ink had deposited it, making images with higher clarity. On the other hand, oil-based ink, being apolar, mostly remains on the paper since it doesn't get absorbed by the capillary action. Furthermore, it also has low surface tension, which is the energy it takes for a liquid to spread out. This means that oil-based ink spreads the pigment over a wider area compared to when it was deposited. However, since it dries so quickly, along with a much stronger adhesion force, oil-based ink is ideal for a wider variety of surfaces, such as plastic and metal. And there we have it. Paper is made of cellulose, which is porous and absorbs water very well, making it ideal for us to write on. There is so much chemistry happening in even basic everyday tasks, such as writing your name on a piece of paper. All of this is thanks to the capillary action behind the cellulose and the ink. Water-based ink is more precise but can be smeared, while oil-based ink spreads out more but can go on more surfaces. I hope that y'all have learned something interesting today. Thank you for watching, and stay hydrated.